Hello everyone. From this video, we are going to start with monotonic stack. And yeah, you are going to find a lot of fun in this topic. It's a very interesting topic. The questions come from this topic. When you talk of stack, we generally talk of questions from monotonic stack and nothing else. Okay, so what do you all get with the word monotonic? Once I tell you the word monotonic, let's suppose, so what you get in your mind? So monotonic means something increasing or decreasing, isn't it? If I talk of monotonic, what you get? You get something increasing or something which is decreasing. That's what monotonic means. Like, let's suppose you have an element over here. Next element is greater than the previous element. The next element is again greater. Next element is smaller, greater, this, this. This is not completely monotonic, but this is some example. Like if you see that this part is monotonic, it is monotonically increasing. Again, this part is monotonically increasing. This part is monotonically decreasing. This part is monotonically increasing, and so on. Like you will get some parts in monotonic, like, isn't it? So that's where the word monotonic comes. Now, how can we relate this to the stack? To relate this to the stack, first of all, you need to understand the type of questions you get. Because from there only you will understand that why we are including it in our stack. The type of questions which you get in the monotonic stack differs. But if you understand this fourth words, if you get to understand these four words, NGL, NGR, NSL, and NSR, then you can solve like each and every question of monotonic stack. You will not get problem in any question. Like you will not get problem in writing the codes, but you need to identify that that's the problem of monotonic stack. Once you are able to do this, and once you know all this stuff, you will be able to understand. You will be able to write down the codes of it. Okay. So let's try to understand that what does these mean. These all are related terms. We will talk of one term NGL, and yeah, you will get the idea that how that what is NGR, NSL, and NSR. These are the short forms which I wrote it down. It's not called like this, but yeah, this is all we have. So if we talk of NGL, so what NGL stands for? Next greater element to the left. So NGL stands for next greater element to the left. What does this mean? Let's suppose you have an array, something like this. Let's it is 1, 2, 1, 3, 7, 4, 2, 3, 8. Let's suppose this is the array given to you. And I tell you for each and every element, just say me the element which is just greater than the present element. If that's the question for you. Like if I tell you for every element, tell me the element which is just greater than the present element. Like the first element to the left of every element, the element which is greater than this element will be our answer. And if you don't have any such element to the left, you will simply keep -1. So let's see what I'm talking about. For 1, there is no element to the left. So there is no element which is greater than 1. So if for this case, the answer will be -1. Okay. For 2, there is no element to the left which is greater than 2, isn't it? So the answer will be again -1. For 1, we have 2 which is greater than this one. So we will just keep it as 2. For 3, there is no element which is greater than 3 to the left of 3. So the answer will be -1. For 7, if you see, there is no element which is greater than 7. So answer will again be -1. Okay. So for 4, the element which is greater than 4 is 7. And so the answer will be 7. For 2, the element which is greater than 2 are many. But the last element, which is just greater than 2, is 4. So the answer will be 4. Similarly, for 3, the element which is just greater than 3 is 4. And for 8, there is no element which is greater than 8, the left of 8. And so the answer will be -1. So this is what I want. I want this answer array. I want this answer array. If you are able to return me this answer array, then the task is done. You can now see that why I wrote it down as NGL, isn't it? It's next greater element to the left. So how you can code it down? Like if you talk of 3, and if you want to get the element which is just greater than 3 to the left of 3, like once you start traversing to the left of 3, and the first element which you get, which is greater than 3, you need that as an answer, isn't it? So just tell me in the worst case complexity, how till where it can go. Like for every index, it may be that you are traveling till the end. So that's for going to every index, you will get a complexity of n. And for traversing to the back of every element, you will again get a complexity of n. So that sums up to like big of n square, isn't it? So this is not feasible. Big of n square time complexity is not feasible. You need to look of some better approach. So this is where monotonic stack helps us. Let's see how. Let's suppose you make a stack over here. Just see the format, how we write down the code. Once you understand this format, then it's very simple for you to write it down. Okay. Let's suppose this is the stack for us. And you want the next greater element to the left. So you will start with the leftmost element. I will make you understand these all codes related from this particular code. So it's better you give full concentration in this code. If you understand this one, these all are like just changing equals to, greater than, equals to sign and all. So it's nothing, some rocket science. So once you understand this thing, it will be easier for you all to get this stuff. So yeah, let's concentrate in this one. How you can find the next greater element to left. See, since you need to find the next greater element to the left, so you will start from the left. You have 1. Since there is no element in the 1, to the left of 1, how you are able to find it? You see that the stack is empty, isn't it? Stack is empty. This means there is no element. What does stack empty denotes? Stack empty tells us that there is no element to the left of present element which is greater than this element. This is what stack empty tells us. So presently your stack is empty. So this tells us that there is no element to the left of 1 which is greater than 1. So yeah, in that case, what you need to do, you need to insert -1 in your answer vector. This is your answer vector. So you need to push back -1. Now once you do that, every time when we come to an element, we need to push that in our stack. So we pushed 1. Okay. Now we came to 2. Once we come to 2, what we will do is we will traverse over the stack from the top and delete the elements which are not greater than 2. And why we are doing this? See, if suppose some elements are there which are less than 2. So if those elements are less than 2, so if suppose we get any element which is greater than 2 to the right of 2, let's suppose we got 3 over here. So if we want to find out, like let's suppose we got 1 over here. Let's suppose if we find out the next greater element to the left of 1, the answer will always be 2 and no other element to the left of 2. If it is surpassing 2, like उसने 2 को pass कर दिया, like ये 2 की जगह ये 3. Let's talk of 3. For 3, if we passed 2, like 2 is not the greater to 3. So every element which was less than 2 will also not be greater than 3. 2 3 से कम था. ठीक है. सो 2 के लेफ्ट में जितने एलिमेंट्स 2 से कम थे वो 3 से तो ऑटोमेटिकली कम हो गए ना. सो दैट कांट बी आवर आंसर. सो व्हाट वी डू इज we traverse over the stack from the top and delete the elements which were less than 2. Okay. So we came to the element and till when we can do this operation? Till the stack is not empty. Because empty stack से तो कुछ delete नहीं कर सकते ना, वो काम मत कर देना. So empty stack से delete नहीं कर रहे अपने लोग. So what we will do is we will traverse from the top and delete the elements. So we came to 2. We saw that the stack is not empty. Okay. We see the topmost element. It is less than 2. So it can't be the answer to any of the elements over here. If it is not an answer to 2, it will not be answer to any of the elements. Like, आप सोचो, if suppose this element is answer to any of the element, so the better answer is 2, isn't it? 2 पहले आएगा ना, किसी के भी लेफ्ट में 2 तो पहले आएगा. So अगर 1 ही उसका आंसर है, like 1 is greater than that any particular element, so 2 is definitely greater. So in that case, you are going to return 2 and not 1. So उसके लिए हम लोग 2 से जितने भी छोटे एलिमेंट है 2 के लेफ्ट में उनको डिलीट कर देते हैं. That's the logic why we do this. Once you code it down, once we dry run this, you will get a good idea of it. Okay. So you came to 2. You checked from the stack from the top, and you got that no element is like the 1 is less than 2, so you will delete it. And the stack is empty now, like you can't delete more elements. So again, since stack is empty, so what does stack empty denotes? Stack empty tells us that there is no element to the left of 2 which is greater than 2. Okay. So in that case, our answer will insert -1 and we will insert the present element to our stack. Why we are inserting this present element to the stack? See, let's suppose you had array something like this 3, 2 and 1. For this, if you construct an answer vector, you will get your answer something like -1, 3 and 2. For 1, you got 2 as your answer and not 3. So while you were constructing the stack, first of all, you pushed 3. Now you came to 2 and you got that 3 is greater than 2. So you will not delete this 3 and you will just insert 3 in your answer. Now once you come to 1, and if you have not pushed 2, अगर हमने 2 को stack में नहीं डाला था तो उसके लिए तो आंसर 3 हो जाएगा. But you need to return the first element to the left of the present element which is greater than that element. So if that's the case, every time we come to an element, वो stack empty हुआ या नहीं हुआ वो हमारा काम नहीं है. That will give you the answer. But for the best possible answer, what you need to do is every time you come to an element, at the end of all the operation, you need to insert that element in your stack. Just keep it in your mind. At the end of all the operation, you need to insert this element at the top of the stack. Okay. So just see, dry run for this one and you will get the idea. So you inserted 2. Okay. Now you came to 1. For 1, you checked that is 2 greater than 1. So the answer is yes. So you will do nothing. You will not delete anything and you will just push back 2 in your answer vector. And you will push back the present element 1. Okay. Now you came to 3. You checked from the top till the stack is not empty and the topmost element is less than 3. You need to delete those elements. So first of all, you deleted 1 since 1 is less than 3. Then you deleted 2 because 2 is also less than 3 and now the stack is empty. You don't have any more element in your stack. So in that case, you know that for 3, there is no element to the left of 3 which is greater than 3. So you are going to push back -1 in your answer. And after doing that, what you will do is you will insert 3 in your stack. Now you come to 7. For 7, again you will go, you will check that if the stack is not empty. So you will delete the elements from the top which were less than 7. So you will delete 3 and after that the stack will become empty. You will push -1 and you will push 7 in your vector. Now you come to 4. For 4, you will check that if the stack is not empty and you will delete the elements from the top which were less than 4, less than equals to 4. So in this case, the number is 7 which is greater than 4. So you will not delete anything and just push back 7 in your answer. Now you come and you will insert the element 4. Now you come to 2. So you check that, okay. So you will again do the same operation, but you will not delete 4 over here since 4 is greater than 2. So you will push your answer as the topmost element of stack, which is 4. So you got 4, and you will insert 2 in your stack. Now you come to 3. You will perform the same operations. You will delete 2 because 2 is less than equals to 3, but you can't delete 4. So the topmost element of the stack is 4. The stack is not empty. So your answer is this. Similarly for 8, and you will delete insert 3. Now similarly for 8, what you will do is you will perform the same operations. Now all the elements over here are less than equals to 8. So in that case, you will delete all the elements. You will get stack as empty. So your answer will now be -1. So this is how you can construct this answer vector. This is the way you can imply that this is the way you can construct your answer vector. Okay. So I hope you all got it. Let's code it down once, and then we can see like the changes which we can make to get stuffs like this. Like next greater element to right, next smaller element to left, and next smaller element to right. We can get this once we make changes in this code. So first let's code it down this one. Okay. Just see the basic template. This is the template which we are going to use in each and every code. So first of all, let's take input in the array. Okay. So now for the answer vector, we can just construct an answer vector. It will be of size n, isn't it? Okay. Now we can make a stack. We are making stack of integers. Now we will run a loop, like we will go to every element, isn't it? So yeah, we will go to every element for checking the element to the left of it, which is just greater from it. So first of all, we need to delete the elements which are less than equals to this element, isn't it, from the stack. So and how when we can delete it? We can delete it till the stack is not empty. So while the stack is not empty and the topmost element of the stack is less than equals to the present element, we will perform the pop operations. We will delete that element, isn't it? After doing all this stuff, if we get that the stack is empty, so if the stack is empty, what does this means? This means that there is no element to the left of this present element which is greater than this element. So in that case, our answer of I will be nothing but -1. And if the case is opposite, like the stack is not empty, so the element to the left of this element which is greater than this element, the next greater is nothing but the topmost element. So answer of I will be nothing but st dot top. And once we are done with this, we need to insert the present element we are in. So we will just do this. Once we are done with this, the answer vector contains the answer for us. So yeah, this is just a basic code which we write for monotonic stack. This is the code for next greater element. Next greater element to the left. I will make changes to this code and you will find that this is a basic template which we are using to write each and every code of monotonic stack. Just try to understand this template and then you are ready to go with it. Okay, so let's dry run for one sample input and then we can get our answer. First of all, let's try to print it once. Okay. Okay. So let's take the input. The elements are 1 to 1. Let's take the same input which we took. 1 to 1, 3, 7, 4, 2, 3, 8. The number of elements are 9. Okay, 1 to 1, 3, 7, 4, and 2, 3, 8. Now let's try to run it once and let's see what's the answer vector we are getting. Okay, sorry. The answer vector which we got is -1, -1, 2, -1, -1, 7, 4, 4, -1. So this is same what we got over here, isn't it? So yeah, it's working fine. In next video, what we will see is we will see all these codes by just making some minor changes to this code, and then we are ready to go with it. By then, thank you.